Alma. Today we're going to be reviewing Unit 4, Science, Chapter 3, Earth and Space Science. At any time during this video, you can pause and rewind. So without further ado, let's dive right into Chapter 3. Welcome back. As always, please remember that we are following along with the GED Test Prep Plus 2020 book. You can look down below for different places where you can go ahead and order it. During this video, we are going to go over Unit 4, Science, Chapter 3, Earth and Space Science, Lessons 1 through 5. We will be starting on page 538. Lesson 1, Structure of Earth. Lesson 1, Structure of Earth. What is Earth? Well, Earth is the planet we are living on. Earth can be described as an almost spherical shape, which is flattened at the poles, the North and the South Pole, and bulging at the equator. Earth's composition consists of 3 layers: the crust, the mantle, and the core. Think of it like a birthday cake. You have the icing, the cake itself, and then the filling. Well, the Earth's layers are just like that. The Earth's topmost layer is the crust. The crust is composed of granite, basalt, gabbro, and other types of rocks. The crust can be found 3 to 6.8 miles under the oceans and 12 to 40 miles below the continents. Below the crust is the mantle. The mantle is made up of silica and metal-rich minerals. And way below the crust and the mantle is the core. The core is made up of 2 sublevels, the outer core and the inner core. The outer core is made up of liquid iron and the inner core is made up of solid iron. So one of the main characteristics of the core is its extreme heat and pressure. Let's move on to the theory of the plate tectonics. Remember, a theory is a system of ideas that is intended to explain facts or events. So now, let's talk about this theory. The theory states that the Earth sits on these plates that fit together, kind of like a puzzle, and throughout time, they move apart. So these plates are called tectonic plates, and they make up the crust of the Earth. According to geologists, the tectonic plates move yearly at a rate of 6 inches per year. That's incredible. The plates are moving and we can barely feel it. At the boundaries or margins of these tectonic plates is where volcanoes, mountain ranges, ocean trenches, and mid-ocean ridges form. So there are 3 types of plate margins. Let's start with the first one. A constructive margin. So a constructive margin is defined by 2 plates that spread apart. However, between these plates, a new plate forms from the mantle layer that rises from below the crust. This phenomenon usually happens at a mid-ocean range or mid-ocean ridge. A great example of a constructive margin is the mid-Atlantic ridge, where a new crust is forming, causing the seafloor to spread and grow by about 2 inches per year. That is incredible. The second type of margin is a destructive margin. A destructive margin occurs when 2 plates are colliding with each other and the crust becomes destroyed. When a continental plate and an oceanic plate collide, the denser oceanic crust is forced under the other plate and ultimately form a trench plate. When a continental plate collides with another continental plate, the crust crumples together, forming mountain ranges like the Andes. Finally, the third margin is called transform or conservative margin. In a conservative margin, two plates slide with one another. There is no new crust made or destroyed, which is good. A great example is the San Andreas Fault in California. The San Andreas Fault is the boundary between the North American plate and the Pacific plate. So whenever the San Andreas Fault moves northwest, an earthquake is created. So far, we have learned about the Earth's layers and the tectonic plates and how they affect the composition of Earth. Based on this information, geologists for many years have sustained a theory how the continents came to be. Geologists believe that the continents were all sitting on one tectonic plate, which is referred to the Pangaea continent. When the plates began to move, the continents dispersed slowly to where they are today. This happened within a time span of approximately 250 million years. With the plates shifting yearly, I wonder, where are we going to end up in another 250 million years? Now that we have finished our first lesson, let's go to practice 1, found on page 539. So for practice 1, we are going to complete questions 1 and 6. So using the text on page 538, answer questions 1 and 6. Take a few minutes to answer them, and when you're ready to review them together, just go ahead and click play. Let's go ahead and get started with question 1. What does the theory of plate tectonics explain? A. Changes in Earth's crust, changes in Earth's mantle, changes in the composition of Earth's layers, why there is an extreme heat and pressure in Earth's core. So right away, we know that B, C, and D are talking about the Earth's layers, which is the crust, the mantle, and the core. So we know that that has nothing to do at this time with the plate tectonics. The plate tectonics, they explain the changes in the Earth's crust. Therefore, the answer is A. Now let's look at 6. Which of the following is a theory rather than a fact? A. The San Andreas Fault is the boundary between the North American and Pacific plates. B. A single large landmass called Pangaea existed about 250 million years ago. C. The Earth's crust is composed of rocks like granite, basalt, and gabbro. And D. Earthquakes often occur along tectonic plate boundaries. So we already know for a fact that A, C, and D are correct, and they are actually a fact because you can definitely prove it. However, with option B, we can't really prove that Pangaea actually existed about 250 million years ago. This is just a theory that scientists have based on what they know today. Therefore, the answer is B. At this time, pause the video, complete practice questions 2 through 5, and click play when you are ready to continue. Let's move on to lesson 2, Earth's resources. The Earth offers a variety of resources to all living organisms. A resource is anything that is needed to survive. Humans need food, water, and oxygen in order to survive, among other things. Some of Earth's natural resources include air, and air is involved in respiration, climate, and weather. Water is another natural resource. Water is used for drinking, cooking, bathing, agricultural farms, and some industrial processes. Did you know that less than 3% of the world's water is fresh water? Minerals is also an important resource. They are an inorganic substance that make up the rocks. These rocks or minerals have an immense amount of uses, such as talcum power, uranium fuel rods, and diamond drill bits, or diamonds. We all know what diamonds are. Energy is another resource that can't go unmentioned. Energy includes fossil fuels, flowing water, solar, wind, and geothermal energy. And last but not least, we have soil. Yes, soil is a natural resource. Soil is an essential earth resource as it is composed of disintegrated rock, organic matter, and living organisms. Soil is used for the growth of vegetation, both wild and agricultural. Resources can be classified into two categories: renewable and non renewable. Let's start with non-renewable resources. Non-renewable resources is just what its name says. It is a resource that once it is used up, there is no more. They are in limited supply. These resources may take millions of years to form, and when they are used up, they are not able to recreate themselves. A great example of a non-renewable resource is fossil fuels. Fossil fuels, which includes peat, coal, natural gas, and oil, are non-renewable resources. These non-renewable resources formed from decaying plant remains. Fossil fuels are our own main source of energy for heating, transportation, and generating electricity. Soil and minerals are also examples of non-renewable resources. A renewable resource is a resource that is able to regenerate itself or be made again. In other words, that is an unlimited supply of it. A great example of a renewable resource is solar energy because it is energy that is generated from the sun. We know that the sun will always be there and won't go away. Another example of a renewable resource includes water power. Water power of flowing rivers, tidal and wave power from the movement of ocean water, wind power from the movement of air, and geothermal power from the heat in the Earth's crust. All of these renewable resources have another thing in common. They are all used as an alternative source of energy to generate electricity. As human beings, we are always looking for alternative resources to power our homes, vehicles, and any other new gadget that is invented. Due to overwhelming usage, consumption, and pollution, Earth's resources are being destroyed and harmed. It is believed that the human population has already used between 1/10 and 1/4 of the world's supply of oil, which is a non-renewable resource. Soil has also been overused between agriculture and erosion. Water is polluted by sewage, industrial waste, and agricultural and urban runoff. Air is polluted by fossil fuel emissions, and its ozone layer is depleted by the release of compounds called chlorofluorocarbons, or CFCs, in the atmosphere. The ozone layer is a thin layer that protects the Earth from UV rays and radiations that are emitted from the sun. With the release of CFCs, the ozone layer is slowly deteriorating, giving way to those pesky UV rays entering our atmosphere. In order to protect the Earth, we need to develop new ways to conserve its natural resources. Conservation is any action that is taken to preserve natural resources and protect the natural environment. It involves a variety of things, such as building more efficient combustion engines, reduce gasoline consumptions. For example, the Tesla runs on electricity instead of gasoline. Using catalytic converters to reduce the harmful emissions of energy, using agricultural methods that protect the soil, building water treatment and sewage treatment plants, safely disposing of radioactive waste, and cleaning up sites that are heavily polluted by industry or human population, such as oceans and creeks. You can start preserving our natural resources by recycling at home. You can recycle glass, plastics, and metal waste. If we all put our part in order to conserve the natural resources of our Earth, we can make sure that the Earth lasts us for another 250 million years. Now let's move on to practice 2, found on page 541. For practice 2, we're going to complete questions 1 and 2 using the graph provided. So take a few minutes to complete those questions, and once you're ready to review them together, just go ahead and click play. For questions 1 and 2, remember to use the graph that was provided, which is world petroleum consumption between 2003 and 2011. Let's start with question 1. Approximately how many quadrillion BTUs of petroleum were consumed in 2011? So BTUs stands for British Thermal Units. So first, let's look for 2011 on the x-axis, which is the year on the far right side. Then we find the line that measures petroleum consumption until we meet with the line graph, which is right there. Once we have located on the graph line, we find the corresponding value with the y-axis. In this case, it's the measurement of BTUs. Based on the graph, we can see that in 2011, there were approximately 177 British thermal units that were consumed. Therefore, our answer is D. Let's answer question 2. Between its low point in 2003 and its high point in 2011, the approximate range of the data regarding world petroleum consumption was blank quadrillion BTUs. In order to find the range, we would need the total consumption BTUs for the corresponding years that the question is asking. In this case, it was 2003 and 2011. We already know that in 2011, there were 177 BTUs consumed based on the previous question. Now we need to find the number of BTUs that were consumed in 2003. Based on the graph, it looks like it was 163 BTUs. Now that we have both measurements, we subtract them from each other, which yield a total of 14 BTUs. Therefore, the approximate range of the data regarding world petroleum consumption was 14 quadrillion BTUs. At this time, pause the video, complete practice questions 3 through 6, and click play when you are ready to continue. Let's move on to lesson 3, weather and climate. Lesson 3, weather and climate. When we hear weather and climate, we sometimes think it's probably the same thing, right? Well, it's not. Weather is the condition of our planet's atmosphere, and it is constantly changing. Weather can be described as hot, cold, rainy, snowy, and climate is the average long-term weather conditions in a region. For example, let's look at Phoenix's weather. It changes day to day Well, sometimes, especially during monsoon season. The mornings can be sunny, but as the day progresses, we can sometimes see rain. Let's say this happens 5 times during the month, and the remainder 25 days were all sunny. In this case, we can say that the climate was mostly sunny for that particular month because remember, climate is a long-term weather condition in a region, not a day-by-day change. These daily weather patterns are caused by the movements of air masses or large bodies of air. These air masses have a similar temperature, humidity, and pressure. The edge or the boundary where more than one air mass meets is called a front. You have a cold front, and a cold front usually occurs when cold air takes over and destroys a warm air mass. We also have a warm front, and this happens when warm air rises over the cold air mass. Last but not least, we have an occluded front, and this occurs when a cold front catches up with a warm front and the systems become one. A primary characteristic of a front includes clouds and precipitation. Where do these changes come from? Well, weather and climate ultimately arise from the uneven heating of the Earth. The sun's rays tend to fall directly at the equator, which is the middle of the Earth, than they do at the North or South poles. The result of this uneven heating causes global wind circulation patterns. So, what does that mean? Well, for one, it means that the warm air in the equator rises, creating an area of low pressure and moves towards the poles. Also, the cold air at the poles sinks, creating an area of high pressure and moving towards the equator, which is the result of prevailing winds in both the northern and southern hemisphere. Another culprit for weather and climate change is ocean currents. Ocean currents are caused by the variations of density of the water. Warm water is less dense than cold water. The ocean current helps carry the heat from the equator to the poles. People who study short and long-term weather patterns and collect data for particular regions are called meteorologists. Meteorologists are stationed at meteorological stations around the world with one common goal: to collect weather data. They collect temperature readings, cloud cover, and wind speeds. Not only are they analyzing data that they are collecting, but also data that is collected through satellites and radar. This data is then used to analyze any future storm systems using the data from years past to predict whether current weather conditions or storm systems that are coming, such as hurricanes, tornadoes, blizzards, and floods. For example, if a hurricane was heading to land, meteorologists would be able to predict the time frame it would take to reach land, and therefore they would issue a warning, providing people with sufficient time to prepare. Now that we've finished with our lesson, let's focus on practice 3, found on page 543. At this time, pause the video to answer practice 3, questions 3 and 4. Choose the best answer for each question. Once you are ready to review them together, go ahead and click play. Let's start with question 3. Hurricanes are violent storms with high winds and rain that form over the ocean. They cover an area of 300 to 600 miles across and move relatively slowly, between 5 and 15 miles per hour. Meteorologists can now predict their paths with a great deal of accuracy. Which of the following technologies best accounts for accurate hurricane tracking? Our options are A, anemometers, which measures wind speed, thermometers, which measure air temperature, the Beaufort wind scale, a method of estimating wind speed, satellites, which transmits cloud photos and weather data. So take a minute to think about it if you haven't completed it yet. The correct answer is D, satellites, which transmit cloud photos and weather data. Anemometers, thermometers, and the Beaufort wind scale only measure one aspect of the hurricane. Satellite photos of cloud patterns help in order for meteorologists to identify hurricanes and follow their paths. Weather data helps them follow changes in the intensity of the storm. Thus, the photos and data from satellites help meteorologists make predictions about the development and movement of hurricanes. Let's move on to question 4. Which of the following help even out the unbalanced heating of Earth as a whole? A. Precipitation associated with fronts. B. Local air masses. C. Tornadoes, blizzards, and floods. D. Global wind and ocean current patterns. According to the passage, both global wind patterns and ocean currents redistribute heat from the solar heating of Earth. Therefore, our answer is D. At this time, pause the video, complete practice questions 1, 2, and 5, and click play when you are ready to continue. We are now moving on to lesson 4, Earth in the solar system. Earth is part of the solar system. But what is the solar system? Well, the solar system consists of the sun, which is a star, planets, satellites or moons, asteroids, and comets. The sun has the highest percentage of mass compared to everything in the solar system, and all of the other celestial bodies revolve around the sun, and they are held in place by the force of gravity. There are a total of 8 planets in the solar system. The planets are listed according to their distance from the sun. We have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. The planets are divided into 2 groups, inner planets and outer planets. They are categorized based on their distance from the sun and their composition. The inner planets, which include Mercury, Venus, Earth, and Mars, are relatively close to the sun. They are also characterized as small and rocky planets. The outer planets, which include Jupiter, Saturn, Uranus, and Neptune, they are located further away from the sun, and they are also known as gas giants. Here are some interesting facts for you regarding the planets in the solar system. Now, I'm not going to go through all of them. However, feel free to pause the video at this time so you can take a look at all the different characteristics of each planet to learn maybe how many moons they have, the distance from the sun, how big they are in diameter, their rotation period, and the revolution period. Let's learn more about our planet, Earth, since, we are living on it. About 70% of Earth's surface is covered by water. It is also the only planet in the solar system where life exists that we know of. Earth's satellites, the moon, is the 5th largest in the solar system. Moon's composition lacks an atmosphere. However, in 1998, it was discovered that the surface of the moon is covered by ice. The moon revolves around the Earth once every 27 days. During the lunar month, the moon goes through phases or changes in the proportion of its surface that is in shadow. The cycle of phases takes approximately 29 days. U.S. astronauts have landed on the moon in several missions from 1969 to 1972, making the moon the only celestial body that has been visited by crewed spacecraft. Now that we have learned about the Earth in the solar system, let's go ahead and look at practice 4 found on page 545. At this time, take a minute to pause the video and complete practice 4, questions 1 and 4. For these questions, you are to choose the best answer. So go ahead and take a minute, and then when you're ready to review them together, just click play. Welcome back. So what are you seeing this chart again? Well, this chart is going to help you answer questions 1 and 4. So take a good look at it and make sure that it is in front of you when we are answering these questions together. Let's go to the first question. Let's go ahead and get started with question 1. According to the chart on page 544, which of the planets takes the shortest time to revolve or complete its orbit around the Sun? A. Mars, B. Saturn, C. Neptune, D. Mercury. Well, a planet's revolution is its orbit around the Sun. So let's refer to the chart on page 544 and locate the revolution period. Go down the list and locate the shortest time that it takes to go around the Sun once. It looks like answer is D, Mercury. Mars takes 687 Earth days. Saturn takes 29.46 Earth years. And Neptune takes 164.8 years, while Mercury only takes 88 Earth days to revolve around the Sun. Let's move on to question 4. According to the chart on page 544, which of the following planets has the most moons? So we are going to repeat the process as we did for question 1. However, in this instance, we're going to look for the column of number of moons. Once we look through that column, we are going to see which planet has the most moons. So our options here are Jupiter, Saturn, Uranus, and Neptune. So Jupiter has 50 moons, Uranus has 27 moons, and Neptune has 13 moons. Saturn, on the other hand, leads them with 53 moons. Therefore, the answer is B. At this time, go ahead and pause the video, complete practice questions 2, 3, 5, and 6 on your own, and then click play when you are ready to continue. We are now moving to lesson 5, the expanding universe. Let's dive deeper into outer space. Let's start with stars. The sun is a yellow star made of helium and hydrogen gas that produces its own heat and light throughout nuclear reactions. Stars usually have a life cycle of 10 billion years. Do you know how a star is formed? I don't, but let's learn together. Stars start as protostars. During this stage, they are formed from clouds of gases and dust called nebulae. When the star reaches a certain density and temperature, nuclear reactions begin, releasing huge amounts of energy. At this point, the star is known as a main sequence star. This stage is also the longest stage in the stellar life. After billions of years, the star begins to run out of hydrogen fuel and then it becomes a red giant. Literally, a red giant. During this phase, two things can happen to it. It can become unstable and collapse, exploding as a supernova and leaving behind a neutron star, or it can lose its mass and become a white dwarf. Let's continue on with the cycle of the supernova. When supernova explode, it leaves behind a neutron. During this stage, the neutron star is very dense and the gravity causes it to collapse in on itself. When this happens, black holes are made. The gravity in the black hole is so great that light cannot escape from them. So we learned about the birth of a star and its life expectancy. So where do all these stars live? Because remember, there are millions of stars forming at one time. Well, they live in galaxies. Galaxies are a huge collection of gas, dust, and of course, stars. A galaxy is held together by gravity. Galaxies differ in shape and size. They can be spiral, barred spiral, elliptical, and irregular. The galaxy where Earth is located is the Milky Way, and it is a spiral shape. The Milky Way has a denser circle and arms that spiral out from the center, as you can see in the diagram. One of those arms is Orion's arm, and guess what? Earth is located on Orion's arm. The Milky Way galaxy is part of a group of galaxies called the Local Group. The Local Group is made up of 27 galaxies. Both the Milky Way and Andromeda are the largest galaxies in the Local Group. Let's explore even more into space. The universe. The universe consists mostly of empty space with galaxies scattered throughout. Aside from galaxies, the universe also has brown dwarfs. No, not the seven dwarfs, brown dwarfs, which are objects that are less massive than a star but more massive than a planet. Pulsars. Scientists believe that pulsars are rotating neutron stars that emit pulses of energy at regular intervals. And finally, quasars, which are distant star-like objects that emit more energy than 100 galaxies put together. I mentioned scientists in the previous slides. So who are these scientists? Well, they are cosmologists, and they study the origin, properties, and evolution of the universe. So how did the universe get created? One popular theory about how the universe came to be, according to cosmologists, is the Big Bang. No, not the TV show, but the phenomenon that created the universe. It began in a hot, super dense state smaller than an atom. The Big Bang caused all the material inside that atom to erupt and ultimately form the universe. The evidence to support this theory is that the galaxies are moving away from a central point, leading scientists to believe that they started in one place. Secondly, scientists have detected cosmic radiation left over from the Big Bang. Cosmologists are unaware what caused the Big Bang. However, they do believe that the universe is between 10 and 20 billion years old. Now that we have finished our lesson, let's move on to practice 5 found on page 547. At this time, pause the video and complete practice 5 questions 4 and 5. Choose the best answer for each question. Once you are ready to review them together, just go ahead and click play. Let's start with question 4. The sun is about 4.7 billion years old. Based on the information on page 546, at which stage of its life cycle is the sun? So let's remember our stages for the stars. We have as an option A, protostar. Well, protostar is the beginning phase. It's the origin of stars, which is made up of condensing gases and dust, which does not align with what the sun is today. The main sequence star phase is the longest stage in the stellar life cycle. The neutron star forms after the supernova phenomenon, which has not happened to the sun yet. And finally, the white dwarf, which is also a result from the supernova phenomena. Therefore, we can conclude that the sun is currently in the main sequence star phase. Let's move on to question 5. Pluto has a diameter of just 1,438 miles. It is made mostly of ice and frozen rock. It is very small and has an irregular orbit. It was originally classified as the 9th planet from the Sun, but it has been recategorized as a dwarf planet within the Kuiper belt. Which of the following is not a factual detail about Pluto? So let's look at our choices. A. Pluto has a diameter of 1,438 miles. B. Pluto is made mostly of ice and frozen rock. C. Pluto has an irregular orbit. D. Pluto should be classified as a dwarf planet. So let's evaluate. Choices A, B, and C are factual details about Pluto, which are things that we can prove. Choice D is not a fact, but rather a recommendation or an opinion of the scientists. Therefore, the answer is D. Pluto should be classified as a dwarf planet. At this time, pause the video, complete practice questions 1 through 3, and click play when you are ready to continue. Congratulations! We are now done with Chapter 3. It is time to move on to Unit 4, Science, Chapter 4, Physical Science. I will see you soon.